Hey guys, today we'll be doing the Unit 2 review over functions. We're going to be doing the we do column, and I will leave the I do column for you guys to practice on your own. So our first question is to state whether or not this relation represents a function. The official definition of a function is that every x has only one y. Has to be only one. So on a graph like this, the way you test that is by doing a vertical line test. So since this is our x-axis, this vertical line represents all the places where x equals 1. And as you can see, it touches on that circle twice. So that means that there's two different y values for that x value. So this is not a function. I'm going to say because x equals 1 has two different y values. Okay, let's look at the next one. So same type of question. State whether the relation represents a function or not and explain. So when you're given a list like this of points, what you want to do is look at your x values. So that's going to be the first number from each point. And what I notice is that all of them are different. So yes, this is -8 and this is 8 here, but this one's negative and this one's positive, making them different. So since all of the x values are different, yes, this is a function. A simple way to put it is that the x does not repeat. Next, we're going to practice evaluating a function. So it says, given the function g of x equals 3x squared plus 1, find the following values. So when they give you a number like this inside parentheses, that makes it input. So you can use that in place of x. So this function that they gave us, right there where the x is at, we're going to put the number that they provided. So we'll have 3, and then I'm going to put in parentheses as well. So -2 raised up to the second power plus 1. So all I did there was this spot right there replaces the x. Then you could just type in the whole thing into the calculator to see what you get. And I get 13. Okay, let's try the next one. So it's the same thing, 3, but instead of x, we're plugging in 3. That needs to be raised to the second power and then plus 1. So only thing that changed is this x became a 3. So again, just throw this into the calculator, and I get 28. Okay, let's look at a next one. So this is also evaluating a function, but this time they don't give you an equation, they give you a graph here. So again, if it's inside parentheses, that makes it our input value. It makes it x. So what you're going to do is you're going to look at your x axis and find the number that they gave us here. So they gave us 3. So find 3. What you want to do is find out what's happening to the line there. So I'm going to follow it down, and it hits the line right here at this point. We're finding the y value that goes with it. So that is the -4. So f of 3 just equals -4. Okay, now let's do f of 0. So find 0 on the x-axis. Then find your function, and it hits right here. The y value of that point is 2. And then the last one is -1. Follow that up to the function, and then find the y value, which is +4. Okay, now, domain and range. So with domain, you want to find all the possible x values. And with range, you want to find all the possible y values. This graph here, see how it's separate dots? So when we do our domain and range, we are going to list all of those numbers separately. So domain, we're going to start with that curly bracket, and let's get the x value of each of these points. So what I like to do is from each point, draw a line down to the x-axis. So make sure that you're looking at the x-axis here. Then you need to list these least to greatest, so you want to go left to right. So you want to go this direction. So this first point is -8. The next one, there's no number there, but it's between the 4 and the 6, so I know that's -5. And I'm just going to keep going. -2, +1, +5. Okay, now let's do the range. So for range, we're going to look at our y-axis. So each of those points, again, I just want to know what their y value is going to be. So I'm going to do a line over to the y-axis. And because we need to list these least to greatest, you're going to want to go bottom up. So the lowest point is this one down here, and its y value is -5. Next one up is -2. Now I'm here on the third one, +2. Next one is at 3, and next one is at 7. Okay, and that would be our range. Okay, the next one is another domain and range question, but this time it's not just separate dots. It is 2 dots, and they're connected by a line. That makes this function continuous. When you have a continuous graph like that, you have to do your domain and range using inequality symbols. So again, I know that domain goes with x, so we're going to look at the x-axis here. So I'm going to, again, do lines that kind of take up the entire space of where my line is at. So my entire function is in between those two lines at -1 and +3. So I'm going to start with the -1. And at -1, if I follow that to the end, that is an open circle. So that needs to be just regular less than. Domain is x. Then over here where it stops, that circle is filled in. So this is going to be less than or equal to, and then that number was 3. So there is our domain. Okay, for range, we're looking at our y-axis. So I'm just going to enclose our shape here. Make sure that the entire shape is in between the two lines that you draw. And we want to go bottom up. So the lowest is at -5, and again, that's an open circle. So -5 is less than y. Then at the very top, that's +3, and this circle is all colored in. So less than or equal to +3. Okay, let's look at another graph. Again, this one is continuous because it's connected. So for domain, we're going to look at our x-axis, which is this one that goes side to side. So we're going to look at the left side and the right side. Okay, so over on the left, it's starting at -8. That circle is open, so we'll have less than x. And it stops at +2, but this circle is colored in. So less than or equal to +2. Now for range, we want to look at the y-axis. So I know the tallest point is here, but the lowest point, you need to make sure your entire shape is in between those two lines. Don't try to do it at the end point because then you're cutting off part of your graph. Your entire graph needs to be in between the lines. So now the least number is -4, but there is no endpoint. There's no open circle or closed circle or anything. So when it's like that, you're going to use the or equal to. So -4 is less than or equal to y. Then the very top has that open circle, and this would be 9, so less than 9. Okay, so that's domain and range of continuous functions. Okay, and then the last one on here, it's also domain and range, but this time we don't have a picture to look at. All we have is an equation to go off of. So what you should do is go to your calculator. You're going to want to go to 1 for new document, and then 2 for add a graph. From there, just type in everything after that equal sign, and it'll give you a picture. Since I can't really show you the calculator here, I'm going to try my best to sketch it. It would be something along the lines of this right here. It's a parabola pointing up. And that lowest point, again, you could do this from the calculator, is going to be at 0, 12. So now, if I do domain, that's a continuous function, so I know I'm going to need inequality symbols. But looking at the x-axis, so side to side, the left side has an arrow, meaning it's going to keep going on that same trend. So it's going to keep getting wider to both sides. So since it extends forever in both directions, we would say all real numbers. Okay, now for range, we want to look at the y-axis. So at the top, again, there's arrows, so it's definitely going to go up forever and ever. But the bottom clearly stops right there. So it stops at that lowest point. So you just need to decide, do we use the 0 or the 12? So since it's range, you're going to use y. And I know that points are always x comma y. So we're going to use the 12. So this would be y, 12. And we need to know what symbol goes in the middle. Since it is going up there, numbers get bigger. That's going to be greater than. So greater than or equal to. Now, one more thing I want to mention is that this function that they gave it to us in function notation. So instead of using y, actually I'm going to erase that. We should instead use what they did, which is g of x. So just like that. That would be the domain and range of that picture. Okay, and that's it for everything on Unit 2. Now try the I do side on your own.